Good morning. Can you hear me? It's 8:30, time to get started. I know it's early. I hope you are awake. I'm still working on that myself. We have great presentations for you throughout the day, so let's get this one started. The first question is actually, can you see me? Okay. Actually, I'm going to step up here. My name is Adina Trufinescu. I am Program Manager for Windows Phone Developer Platform, and I will present the new mapping capabilities available in Windows Phone 8, as well as new ways you can take advantage of location services to enable you create compelling scenarios in your existing applications or yet to be written apps. In other words, we'll have fun for the next 4 hours. And I'm just kidding, because I have slides and demos and content that I could rather fit in 4 hours. So this is going to be a fast-paced presentation, and we'll have demos, and I will ask you kindly to hold your questions until the end. I have 4 topics that I will cover. First, Location Service API. Do you like writing code twice for tracking the user's locations, once for desktop and once for phone? Anyone? I didn't think so, and you don't have to, because the same set of Windows Runtime APIs for location is available on both platforms. Second topic, map control and services. Our close collaboration with Nokia produced an outstanding map control, and I will talk about that. Third, location tracking in the background. Yes, multitasking for location is in, and I will show you how it works and what it takes to enable that. And then the last topic is Fast Resume. And you might wonder, how is Fast Resume related to location tracking apps? Well, stick around and you'll find out. Location Service APIs. Those of you who are familiar with our platform already have used, most likely, our Location API. It's a straightforward API. It allows you to track the user's location changes, where you set the desired accuracy in 2 levels, high or low. You set the movement threshold. It has 2 events, the position change and status change, and it has 2 methods that you can use to start and stop tracking the location. In addition to this API, and in an effort to align the 2 platforms, we are bringing over the Windows Runtime API for location. And conceptually, this API is similar to the .NET API, but the functionality is way richer. In addition to distance-based tracking, you can track the location periodically. You can set the desired accuracy in meters, and best of all, you can read the current location in a single location request. When you do that, you have the ability to decide on whether to use cache data, and you can set the maximum acceptable age of the data in the cache. And you can also set the timeout, which is the time that your application is willing to wait until the asynchronous API comes back with results. Whether you use the single location request or whether you are tracking the user's location changes, you have the ability to read the source of the position, whether it's GPS, Wi-Fi, or cellular. So no more second guessing. What I want to show you here are 2 code snippets, one for location tracking, and the other one is for single location request, where you have to use the geolocator object, which is the object at the central of the Windows Runtime API. And you set either the movement threshold or the report interval for periodic tracking. If you set both, the movement threshold is going to take precedence. So you have to make up your mind on which one you are willing to use. You attach a delegate on the position change handler, and at that point, the location service will start tracking the user's location, and it will track raising the event inside your application. A difference between this API and the .NET API is that we don't have the start and stop methods. So the moment you hook up the delegate on the event, basically you get started and you're ready to go. And then to stop tracking the location, you unhook the delegate on the event. Now, looking at the single location request, you use the same object, the geolocator. You set the desired accuracy in meters. In this case, I set it to 10 meters. And then you invoke the asynchronous API, the get geoposition async, And you can invoke it with default parameters, or rather no parameters. Or in this case, I'm setting the age of the cache to 1 minute and the timeout to 30 seconds. The thing to pay attention to here is that the higher the accuracy, the longer it takes to the location service to come back with a result. So if you have the application that needs accurate readings from the location service, in that case, you have to give the API a little bit more time to come back with a reading that matches your desired accuracy. If you have the kind of app where the location can be read within, let's say, 100 meters, then you can set the timeout to a lower value. What you don't want to happen is to set a desired accuracy very low and also a timeout very low. So at that point, the API will keep on timing out, and what you get back is a position, but it doesn't have the accuracy that you desire. So tips for location applications: use the single location request whenever it makes sense for your app. Consider leveraging the cache data for faster results and also for saving the battery. Find a trade-off between the accuracy and timeout. And you might consider checking whether Wi-Fi is enabled or rather disabled. And if it is disabled, suggest the user to turn it on. And the reason is because when the user is indoors or in an urban canyon and the location service cannot reach the GPS, then it needs to fall back onto cellular or Wi-Fi. And Wi-Fi is way more accurate. So something to keep in mind. Now, let's look at the map control and services. In Windows Phone 8, we have a new map control powered by Nokia's mapping technologies. And when we designed this control, one of the main goals were that users have the same mapping experience wherever they use the maps on the phone. To achieve this goal, built-in applications, as well as applications in the store, will share the same mapping data and the mapping core functionality provided by Nokia. We work closely with Nokia to integrate their technologies inside our OS, and as a result, the store applications take advantage of rich map data and map functionality, anything from vector maps to 3D landmarks, pedestrian features, 4 cartographic modes, and much more. Even better, Nokia's mapping data is available in more than 110 countries and languages, and they are committed at keeping this data updated and fresh throughout the time. The mapping data on the phone is available offline. This data can be downloaded by the user through the means of the map downloader page in the settings application, but it can also be preloaded by the OEM when they build the phone image for a certain market. Through the map downloader page, the user can also accept updates for the maps that they have on the phone, or they can download the map when they don't need it. The map downloader page is also available to applications in the store through a map downloader task. And once the data is downloaded by either a third party, an application on the store, or a built-in experience, it's become available to any applications on the phone. It is being shared among all applications on the phone. And that way, we store the data once and we download the data once. When you use the map control in Visual Studio, you'll notice that it is not available in the designer. And the reason is because the control is not a pure .NET control, but is rather a hybrid between .NET and native. And actually, it has the bulk of functionality is written in native code. That gives us the opportunity of moving the heavy-duty computation off the UI thread, such as the rendering or gesture input or the calculation of the positions of the UI elements. And because of that, what we got back is a significant performance gain. So once you start compiling and running the application, you'll notice that the control has smooth interactions, that the gestures are responsive. You'll notice the high frame rate. So we had to make the trade-off between the developer experience and the user experience. Another cool feature of the map control is the ability to display routes. These routes can be calculated with the map services APIs, also provided by Nokia. And drawing the route doesn't require you to do the line-by-line drawing, what you have to do is you invoke an API to calculate the route, and then you invoke an API to display the route on the control. And with that, let's look at the map services APIs powered by Nokia mapping technologies, which have 3 functions. Geocoding, which is taking a lat-long position and converting that to an address. Reverse geocoding, taking an address and convert it to a coordinate. And then routing, the one that I've just mentioned. And then for routing, what you have to do is to create a route query where you set the initial position, the destination, and the waypoints. And then you make the API call, and what you get back is a route object with a collection of route legs, and which are in turn a collection of route maneuvers. To use the map control and the service APIs, you need 2 security capabilities, map and location. And when you run the control on a developer unlock phone, you don't need to be registered. But when you run the same application on a consumer phone, you need to register you need to collect your developer token from the dev center, add that inside the application, and basically that will enable the control to execute on the consumer phone. And in addition to the platform APIs, we also provide the map tool extensions, which is part of the Windows Phone Toolkit, available for you to download. And this toolkit gives you additional functionality, such as more controls, push pins, helper methods to convert geocoordinates between the .NET API and the Windows Runtime API. And with that, I'm going to hand it off to my colleague, Mike, for a quick demo.
Thank you, Adina. So what I'm going to cover with you today is a very common scenario we found in store apps, and that is having an app that wants to display a list of stores on a map and then give users directions to them. So what I'm going to start with is I'm going to start with the default data binding project with a slight modification. You can see right now this is what you normally get when you start a default project, but what I've done behind the scenes is I've added to the data set geocoordinates for each one of these entries. So when we display it on a map, it'll be interesting. Before we get started, one of the most important things to remember to do, or you'll get a little frustrated, like I think all of us have while working on this, is remember to set the map capability. Adina called it out, but if you don't set this map capability, since this control does use OS components, you'll crash when you try to load the control and be very confused unless you look at the interception. So make sure you set that map control. Then the next thing, since the technologies in this demo we're going to use is our new map control, our toolkit extensions, and also our new reserved app communication for turn-by-turn, we need to make sure that we include the Windows Phone Controls Toolkit under References. And so you can get this from phone.codeplex.com, and you can add it into your project through NuGet. Great. Now that we've done that, I'm going to go back to our main page and modify this so we can show the map. So I'm going to take what we normally have here for the list and just comment it all out because we don't need it today. And go down here and add our map control. So what we have here is we have a map control, our new map control called Content Panel. And then inside of it is our toolkit extensions, a method called Children. And in there, we're adding our user location marker. User location marker is our new control that emulates our what we internally call MePOI, that shows the user location. It's a little diamond in our app. We're now exposing it so everyone in their app can use the same location marker as we do. And we're going to call that user location today. And then inside of that is a map items control, and that's going to be where we data bind to our list, our view model, our model. And then the last one is a drop pin, which we're not going to use in this demo. I'm going to provide this source, and there's additional demos that I'll go through in a blog post as well. So now if we go back, we'll be able to see in the designer that we now have our map control. And as Adina mentioned, we don't get any design time, but we have a nice little icon, much like IE does in their control as well. All right, so let's go to the code behind main page. First thing we need to do is in our constructor, we need to do a few extra steps. I'll show you them here. We have to call something called map extension setup. This is part of the sample that we give out with the toolkit extensions. It essentially does the same thing as initialize component does, but for our map extensions. Then after that, we're going to explicitly set the store's item source to our model, and then explicitly set our user location to the model. And for default for today, our user location will be the Space Needle, because it's a great place to check out. Maybe when it's less rainy, though. Next, when we load the page, the map will default to zoom level 2 and showing the whole world. And that's not really something that's very useful. So the first thing we're going to do is we're going to talk to our map and ask it to set the view to the user's location at zoom level 14, which is usually a pretty good level to show where the user is on a map and they recognize where they are. Then after that, we're going to do something that's very important for your apps you submit to the store. We need to set the credentials that you'll get from dev.windowsphone.com for the Maps control. These are different than the ones that in the previous control that you used to get from the Bing Maps portal page. These are specifically for the new control. And you need to make sure that you load them after the map has been loaded, like this. All right, so we have the map. We've data bound our points of interest, our stores. And now we need to do something when they click on the store. We probably want to give driving directions. And so we have a pushpin tap method. And what this will do is it will launch out, just like on the default data binding project, out to a details page. And so we're just taking the ID from our model and navigating to the details page using that ID. So now let's go and check out our details page. So our details page, much the same as the default template, but I've added one new item called Drive. And that Drive is now going to be tappable. And when we tap that, we're going to launch out to our turn-by-turn navigation app. So to show you how we do that, we have Drive tap. Inside here, we're going to get the item itself. We're going to pull out its latitude and longitude and name. And then we're going to construct this URI. So Microsoft has a set of app-to-app communications, like MS Drive 2, which are reserved in a way that we are encouraging implementers to all implement them the same way, and so that we can launch from our experience to them and other people can call them. So there'll be a set of turn-by-turn applications, one being Nokia Drive and others, that will understand this on the other end. So now any app can launch directly to driving directions. And so we just have to set the latitude and longitude and the name, and then we invoke it as we would any other app-to-app communication using the Windows RT API launch URI async. So let's check this out on the emulator. Here we go, zooming in to zoom level 14. And you can now see all our points of interest all displayed on the map. You can see we're nicely located at the Space Needle with our user location marker. And so now let's choose to go to Pike Place Market down here at runtime 2. And now we get the details page with the Drive button. And one thing I'm going to say, this is the emulator. And so by default, it doesn't have any turn-by-turn apps. So I've put a little stub on that will flash the Nokia Drive splash screen and then come back. So now when we click on this, see the Drive splash screen, and we're back. So if this was a real phone, that would bring us to the turn-by-turn app, and your users would be getting turn-by-turn directions to your store. And so this demo and a few others will be available on a blog post in the coming weeks. And back to Adina.
Thank you, Mike. All right. So we have a new map control, but we have an existing map control. Which one are we supposed to use? So the Bing map control is still available for 7.x applications, whether existing ones or the ones which are still to be created. But the Bing map control is being deprecated for 8.0 apps. If you choose to use it in Visual Studio, you will get a warning, but you'll still be able to build your application. The control is going to work because it works for 7.x. But our recommendation is to use the new control because it has richer functionality and it has the ability to access data offline. So for all intents and purposes, the Bing map control for 8.0 applications is deprecated. So to recap, we have a new map control and map services powered by Nokia. We have a map extensions toolkit for you to go and download. Users can manage map data offline on the phone, and the Bing Map Control is deprecated for 8.0 apps. And with that, let's move on to location tracking in the background. In Windows Phone 7.0, our developer platform didn't have any multitasking capabilities, and not because we didn't think it's important, but because we didn't have the time to do it right, to do it in such a way where the applications running in the background do not impact the foreground experience. In 7.5, we added multitasking, but there are still two scenarios that are missing, and that is location and VoIP. Both of these are now available in Windows Phone 8, and I will talk about location and show you how it works. The multitasking model for location is not agent-based, but is rather the whole application that continues to run in the background when two conditions are being met. First, the application needs to add the location tracking attribute inside the manifest, this way informing the OS that it has the ability and desire to continue running in the background when it tracks location. The second condition is at the time when the app makes the transition from the foreground to the background, it needs to actively listen for location changes. And it doesn't matter which API it's using, whether it's using the .NET API or the WinRT API. What's important is that the app is registered with the location service, and it gets to get location changes continuously. And this functionality was created for applications such as drive applications, like navigation applications, or sports applications that track the user's workout. And it was not created for the kind of app that needs to read the location occasionally, depending on the application lifecycle, whether on launch or on activated, or depending on the user input. There are constraints to this model. The first constraint is that this functionality is available only for XAML applications. And by that I mean the old Silverlight application, which it's either pure XAML or XAML with Direct3D or XAML with native code. So in other words, you don't have this functionality available if you build a pure Direct3D app. The other constraint is that we can allow a single location tracking app running in the background, and that is because there is as much as you can run in the background without impacting the foreground experience. When you have an app running in the background and yet another app makes the transition from the foreground to the background, the initial app is going to be deactivated. And then applications running in the background have limited access to resources. So let's see what that means. The CPU allocation is capped at 10%, which is high enough for the application to go by, but low enough so that it doesn't impact the foreground experience. The app has access to a bunch of resources, but it doesn't have access to camera or microphone. And that is because of privacy concerns, and that is also consistent with our multitasking model for other features. The app doesn't have access to the screen. It cannot draw. So the only way it can interact with the user via UI is by popping up a shell toast or by updating its own tile if it has one. Now, user awareness and control. Applications that use location use the location capability. And when users consent for the application to use their location when the app is downloaded, they consent for both running the app in the foreground or in the background. Basically, there is no distinctions between the two. So for the user to know whether the app is running or not, they have to go under the settings page, under applications, background tasks, the same page where they check the rest of the agents that run for other multitasking scenarios. And the application is going to be listed there. And they have the ability to tap to close the application. And they have the ability to disable the background functionality per app basis. The app running in the background will continue to run until it either gets moved to the foreground because the user returned to the app, or until the app is being closed because the user tapped on the closed link, on the close button on the settings page, or until the OS deactivates the application for one of these reasons. If the app itself stops tracking location, then one of the two conditions needed to run in the background is not met anymore. And this would be a scenario where, let's say you have a Drive application, the user reaches the destination. At that point, the app is done doing what it has to do for the user. So there is no point actually in running in the background. And there is no point in keeping the threads up and running and spinning. So actually, it is a good thing that applications decide at some point that they stop tracking the location and they get deactivated. When the user disables location services on the phone, naturally, nothing runs, no applications can track location. So in that case, they are being deactivated, or they don't even move to the background to start with. And the app is also deactivated if the user didn't return to the app within 4 hours. We consider that the user lost interest in that application, and we would rather deactivate it to conserve power. And speaking of power and battery, when battery saver is turned on at all times, applications tracking location cannot run in the background. But that is also being the case when the battery saver mode is actually on, when the phone runs in battery saver mode. And that would be the case when the battery reaches 20% and the phone switches to battery saver on. So in that case, if you had an application running in the background, the OS is going to deactivate it. We've talked about how another application can cause the app running in the background to be deactivated. And the last condition is low memory. You notice that there is no memory cap on the applications running in the background. But what happens there, if the OS reaches an out-of-memory condition, the first thing it does is to tombstone the suspended applications on the backstack. And then as a last resort, it's going to deactivate the running application, and then it's going to tombstone it. Every time when the app is being deactivated, it receives the deactivation reason. And we highly encourage applications to notify the user, because if the application is doing something interesting or critical to the user, they really want to know if the application stopped running. And I'm thinking here navigation applications. Now, I want to show you a quick demo. Oops. Which one is mine? Sure. OK. So what I have here is the Endomondo Sports Tracker app. This is an app written by a company in Denmark, and they've been kind enough to allow me to demo the app for you. And I'm going to show you a run that I'm simulating in the emulator, where I'm pretending to run between Microsoft buildings in the rain, pretty much the same way you have to do for these couple of days. And I will start the app in the foreground. I will start the workout, and I will play the points. And you'll notice that at each mile, the application is going to give me some statistics. And don't worry about how fast I run. I promise I can't do that in real life.
1 mile in 12 seconds.
All right. And now, let me send the app to the background. And run again. Running.
2
All right.
miles in 31 seconds. Lap time 19 seconds.
Whew. OK, and what I want you to...
3 miles in 37 seconds.
I'm going fast.
Lap time 5 seconds.
What I want you to see is what happens when I disable
Workout
location.
paused.
OK, so the application informed the user that because of location services have been disabled on the phone, now the application stopped running in the background. So that is the experience that we recommend. Basically, you can use Toast or you can use audio and inform the user that the application is not active anymore. OK, let's come back to the slides. And let's look at the application lifecycle events. When an application moves from the foreground to the background with the purpose of being suspended, it receives the deactivated event handler. But when the app moves from the foreground to the background with the purpose of continuous running, then we have a new event called running in the background. And when the application gets this event, it needs to do a couple of things. First, it needs to pay attention that now it cannot draw. So it needs to fall back to other ways to interact with the user. And that could be the toast, or that could be audio. And the other thing that we recommend applications do is, if they can, they should minimize the memory footprint, because the smaller the memory footprint, the higher chance they have to continue stay loaded in memory. And then the other recommendation is that if the app has timers, animations, or sensor readings which are not relevant to the functionality in the background, then stop this. Because when you stop this, you actually conserve power. Now, this is the application lifecycle for the regular application. Some of you have seen this before. We created this back in 7.0, and we're building on top of this. So the app is running in the foreground. The user navigates away. The app gets the deactivated event handler. App moves to deactivate it and then suspend it. And when suspended, the app can go to Tombstone if the OS needs to reclaim the memory. Or it goes back to activate it, gets the activated event handler, and then back to running. So the difference between this and the location tracking in the background is exactly this. So the app is running in the foreground. It receives the running in the background event. Now it is running in the background. There, it can be suspended or tombstone, the way I explained to you before. Or from there, it can go back to activated and to running when the user relaunches the app. Looking at the launching and closing events, this is the typical app. It goes from launching to running and then to closing. And if you throw the running in the background to the mix, then from running, the app goes to running in the background. And then if the user closes the app from the settings page, then the app gets the closing event and then moves to closing and then not running. It's fairly straightforward. So tips for running in the background. Use sound and toast wisely. Make sure that there is a purpose and an intent, and make sure that the user understands what are you doing in the background and why do you have to give them the notice for whatever scenario you have. Inform the user when the app was deactivated if you think that the functionality that you provide is critical. Stop active timers and animations which don't contribute to the background functionality. Stop tracking location when done to conserve battery. And then the last one is optimize for fast resume. And this is the point in the talk where I really have to tell you about fast resume, and I really have to tell you how is this related to location tracking applications. So what is fast resume? Take the example of a navigation app that has the ability to run in the background. The user starts the app provides directions in the foreground, and then at some point, the user gets a toast. They tap on the toast, the app moves to the background, the user does what they have to do, and then at some point they want to go back to the app. So what users do sometimes is use the back button. And the back button is the fast, reliable way to return to the application. But what users also do, more often than not, they hit the start button. And then they land on the start screen. And there on the start screen, they see the application tile. And what do? They tap on the tile. And what do they expect? They expect that the application resumes, and resumes fast. And this is even more critical for location tracking applications, because the user expects that the app will transition seamlessly from the background to the foreground, and it will continue doing whatever it was doing in the background. So this is where fast resume comes in. Fast resume is the activation policy that enables applications to resume when being relaunched from start, instead of being replaced where the existing application instance is being terminated and a new application instance is created. And fast resume is applicable for location tracking applications, but not only. Any application written for 8.0 can opt into the fast resume model. And the way they do that is by adding a manifest attribute called activation policy resume. And for applications that don't do that, as well as for 7.x applications, the activation policy is still replace. This is the 7.x replace activation policy, where the existing app instance is replaced with a new instance when the user taps on the tile on start. Now, fast resume gives you exactly that, the ability to resume fast your application from start. But that doesn't mean that the application is not going to be suspended or that it's not going to be tombstoned. So when the application is tombstoned because it's been a while since you've used it and there were other applications in the foreground that needed the memory, when the user taps on the app tile, the application is going to resume the user experience, but that will be slightly slower because we have to start fresh with a new instance of the application process. Now, what is the optimal fast resume experience? And the answer is, it depends. It depends from where the app was originally launched, and it depends how the app is now relaunched from the start, and also it depends on timing. So let's see what that means. If you have an app that was originally launched from the main tile, and users use the app, they go a couple of pages in, and then they navigate away, and 5 minutes later, they tap on the application tile, then users will expect that the application resumes the experience because they've just used the application, and they want to continue doing what they're doing. But if I use the app now, and I have n pages on the stack, and I'm using it 5 hours later, I already forgot what I had on the stack, and actually I'm not even interested in what I had on the stack. So in that case, it might be reasonable to start fresh, to start with the home page inside the application. So timing matters. The other scenario is when you start the app originally from the main tile, and then you restart from a secondary tile. So when you restart from a secondary tile, you don't want the application to resume because it will resume the page at the top of the stack. So what you want is to navigate to the page that the secondary tile points to. So when you do that, when the user hits back, what they expect is that they go back to the start screen because that's where they came from. So like I said, the optimal resume experience depends on what the user was previously doing and what are they doing now. And I want to show you a more concrete visual example. But before I do that, I want to make another point. In 7.5, when applications are being restarted, when users tap on the main tile, if the app had a bug in the previous application instance, then that bug most likely will clear up when the user is relaunching the app fresh from the tile. We don't have that flexibility with fast resume because we are reusing the same process. So if the user wants to have the ability to start fresh, to start a new application process, the only way they can do that is using the back button to exit the application. So we have a certification requirement that applications do not block on back key press, but this is even more important if the application is doing fast resume. So I wanted to give you that and to understand what's the motivation there. Now, I have here a mock-up of the Facebook application where I created two tiles on the start, one for the main page and one for Places page. And what I want you to see is what is the user experience if I do nothing but adding the activation policy equals resume in the manifest. So I'm starting from the main tile. I'm launching Facebook. Now the start screen is on the back stack. I land on the first page. I pan. I go to Friends, and I tap, and I bring up the Friends page. Now on the back stack, I have the main page. I hit Start. The Friends page goes now on the top of the back stack. And let's say 3 hours later, I launch Facebook from Places. And I expect to land on the Places page, which I do. But now I want to go back. And when I go back, I expect to go back to Start because I already forgot what I had on the page stack. So when I go back, I expect to go to Start. But what happens is I actually land on the Friends page. because that was at the top of the stack. And I hit back again, hoping to go to start, but no, I'm going to go to the main page because it was on the page stack. So it takes yet another back to go to start. So this is the user experience if you do nothing but adding the activation policy to the manifest. But this is not terrible, but this is not a good user experience either, and we can do better than that. So let me tell you what needs to be done to fix this. So this is the scenario where the application clears the page stack. So same scenario, the app was launched, 2 pages on the backstack. I launched from Places. And then here, before the Places page is being created, the application could decide to clear the page stack. And when it does, those pages move away, and then the Places page come up. And when I hit back, I go back to the start screen. And the other scenario that I want you to see is same thing, Facebook with 2 pages on the backstack. I tap on the main tile, and here, if I don't do anything, a new main page is going to be created, because that is the page that the tile URI points to. But that's not what I want. What I want is to land on the Friends page and to resume the previous experience. So what I can do, or what the application can do, is to check that initially it was launched from the main tile, and now is being relaunched from the main tile. And when that happens, then cancel the navigation to the new page, to the main page, and then land on the Friends page, which is what the user would expect. So how is the application supposed to know when to cancel the new navigation or when to clear the page stack? The app needs to pay attention to the navigation events. The page at the top of the stack, when the application is being relaunched, that page gets the navigation mode, gets a navigation event with navigation mode reset. And it is at that point where the app needs to make a decision on whether to clear the page stack or cancel the forward navigation or possibly do nothing. If the app doesn't decide to cancel the forward navigation, a new page is going to be created for the URI that the user tapped on, and that page is going to be navigated with navigation mode new. And then we have yet another case when, if the user launches the page with a URI which is exactly the same as the URI of the page at the top of the stack, then in that case, we don't create a new page, and the app at the top of the stack is getting a refresh, and it has the ability to refresh its content. So let me show you a diagram that will illustrate the order of the events. Imagine that you have 2 pages on the backstack, and now the user taps on the application tile. So the page at the top of the stack is being navigated to with navigation mode reset. And then it is being navigated from with navigation mode new. And if the application does nothing, a new page is being created, and that page is being navigated to with navigation mode new. And it is at this point where you can come in and decide whether to clear the page stack or to cancel the navigation. So let's see how that looks. If you want to resume the previous experience, you have to cancel the navigation. So the top of the page gets navigation mode reset, and then it is being navigated from with navigation mode new. And then exactly at this point, you can cancel the navigation. And when you do, basically, the user lands on the previous page, and the application resumes. Now, let me show you the start fresh scenario, which is typical to deep links. So the page at the top of the stack is being navigated to with reset, and then navigated from with new. And then right there, you can decide to clear the page stack. And what happens is the page is being created and navigated with navigation mode new, but the 2 pages that were on the backstack are being cleared up. So this is the case when you start with a deep link. You create the page associated with the deep link, and then when you hit back, you go back to start because the 2 pages have been cleared up. Now, let me show you a quick demo of how the code for that would look. What I have here is a super simple app on which I did nothing but adding the activation policy equals resume in the manifest. Let me show you here. So what I have here is the activation policy resume. And what I want you to see is the application behavior when I'm doing nothing. So from this page, you can go to page 1. From page 1, you can go to page 2. And then page 2 also has a deep link. Now, let me show you the relaunch experience. I start from the main tile. I go to page 1. I hit start. And now I relaunch from the main tile. And what I was hoping there was that I can resume the previous experience, that I can land on the blue page, on page 1. But what happened there, a new main page was created because that was the page associated with the tile. And when I hit back, I go back to page 1 because that was on the back stack, and then back to the main page. Let's try again. Now go to start, and let's go and launch page 2. And in this case, I don't expect a resume because I want to land on page 2, when that is great. But when I go back, I don't go back to start from where I came from. I'm going back to page 1 and main page because these were on the back stack. So there are two problems that I want to solve here. First, I want the application to resume. And then second, I want the application to clear the page stack when I relaunch from a deep link. So let me fix the first issue, the resume issue. And I want to tell you that there are multiple ways to enable the application to do resume. You can do it at the page level, or you can do it at the root frame level. It's more complicated at the root frame level, but you don't, the advantage is that you don't have to make code changes on each page. For the sake of simplicity, I'm going to show you how to do it at the page level, and the SDK sample that we have actually has the code written for the root level navigation. So on page 1, which is the blue page at the top of the stack, when the page is being navigated to, I check that the navigation mode is reset. And if it is, I'm going to set this member, cancel new navigation, to true. When the page is navigated from, I check to see whether cancel new navigation is true, which means that I'm in the middle of a reset navigation, and now the page is navigated from. And here, before I forget, I'm going to set this guy to false. And here, I check that I have a navigation to a new page, and that this new page is actually the main page. And when that condition is true, eCancel equals true. Basically, I canceled the navigation to the main page. So let me see if it builds, and now let me run it. So I go to main page, I go to page 1, I hit start, and now when I start from the main tile, I resume the previous experience and I land on page 1. So let me show you this one more time, and I will enable the breakpoints. This is not interesting, and let me restart here. And on page 1, on the blue page, when it is navigated to and the navigation mode is reset, I come here and I set the cancel new navigation. Now hit 5. And when the page is navigated from, the URI is for the main page, the navigation mode is new, and when that is being the case, I cancel the navigation. Now, the second problem that I want to solve is clearing the page stack for when I relaunch via a deep link. So what I'll do, I'm going to go to the app xaml.cs, and what I'll do here, I will uncomment this line. And this is code that I didn't even have to write. This code is part of the project template. And what it does, it hooks up the check for reset navigation at the root frame.navigated event. And what this one is doing is checking that the navigation mode is reset. And then if it is reset, then next time, for the next navigation, which is going to be the navigation for the new page, this clear backstack after reset is going to be invoked. And right here, I'm going to clear the page stack. So let me show it to you first, up and running. So I go to page 1. I hit start. I launch from page 2. And now, because I cleared the page stack, I'm going back to start. So let me show this to you with breakpoints enabled. Actually, it's too early. Let me do this. OK. Shoot. OK. Now I'm going to enable the breakpoint. And I will restart page 2. And here, check for reset navigation is being fired. I hook up the clear backstack after reset. On page 1, which is the blue page at the top of the stack, I still come here with navigation mode reset. My code for checking whether I need to cancel the new navigation is still in there, but because I'm checking that I'm checking the URI against the main page, then this code actually becomes a no-op. You'll notice here that the URI is for page 2. And then the last thing that happens is the clear backstack after reset is being invoked, where I clear the 2 pages on the backstack. And then one more thing, page 2, which is the purple page, is being created and is being navigated to with navigation mode new. OK. So I know it's not super simple, but I hope it's not super complicated either. You guys tell me. So things to remember. The rule of thumb is that when the users relaunch the app from the main tile, resume the previous experience, and decide whether, depending on timing, you want to start fresh. For deep links, consider clearing the backstack and giving the user an appearance of a fresh start. Do not block on back key press. Make sure to test relaunching between primary tile and deep links. And do not forget tombstoning, because it's still applicable. So in conclusion, you have an outstanding map control and map services powered by Nokia. You have access to a Windows Runtime API for location. You can enable background execution for location tracking applications. And you can use fast resume for all applications built for 8.0. And resources, I'm giving you the link for the Map Toolkit extension. And if you are interested to learn more about the app-to-app communication for the scenario that Mike brought up, where you can launch a new URI for a navigation application, then make sure to go to the app-to-app communication session. And then with that, I'm going to open the floor for questions. Thank you. There are mics.
Hey, is it still possible to locate any control on a map?
Locate any Yes, you can put any UI element in a map overlay or on that child elements or a map items control that I showed. Yes.
Thank you.
Hi, so are we supposed to still be using the Bing control on Windows 8 and then the new control on Windows Phone 8? So two different?
Right, there's two different controls. Windows 8 has one that's been provided as a add-in that you can download separately for the Windows 8 store apps. And then for us, we have this Nokia control. And we also still have the legacy Bing control as well on our side. One of the reasons we're pushing you towards this new control is because you get to share the offline maps and you get to take advantage of that.
You don't know of any plans to provide the same kind of Nokia features on Windows 8 that's completely different?
We have nothing to announce about that.
Okay.
Nothing announced, so I guess that means it's hopefully coming. I have a zillion questions, but I'll try to just stick to a couple. Can you still do custom tile overlays with this one?
Yes, we have tile source, same parameters, pretty much.
So
yes.
is it the tile source? Is it just where you pass a string, or is it like a class, like it was with the Bing Maps one?
Josue, do you know?
The Newton source?
Oh, just talk. He has you.
Hi, I'm one of the developers of the map. Hello. Oh yeah, it works. Hi, I'm a developer in the maps team. So for the tile sources, what we have is basically parity with all map control, where basically we take a URI and we take care of the heavy lifting of downloading everything, caching, and displaying it at the right position, etc., etc.
But does it only allow you to pass a string for the URL for the tiles, or can you? The old one used to allow you to pass a class, like a tile source class, I think it was.
On that particular aspect, we made it easy. You just give us the URI, the HTTP mobile dot blah blah with the specific parameters, and that's basically it.
Okay, I'll get with you afterwards.
Yeah, follow up afterwards, and we'll talk about your scenario.
One last one. Do you guys still support drawing polygons on the map?
Yes, we have polygons, and our polygons actually will tilt with the map when you use tilt.
I've got a question for orienting the map with respect to the device orientation. Do you have to do that manually to hook it up to the sensors, or is that something that's included?
No, you have to hook it up manually, but we do now actually support rotation and tilt on the map, so you can do that now.
And do you have, you talked about examples, do you have something that does that?
I don't personally, but we do have some on the team, so if you need something, we can show you later. We'll be at the booth.
That's all? All right.
Oh.
A question about custom tiles. When you provide URIs for your custom tiles, will those tiles be cached, or will they be cached between instances of maps if you do provide them in different applications?
The cache is per application for the tile source.
However, the cache is enabled. Is that right?
So in that specific case, the cache is only per application and only during the the lifetime of the application. A typical scenario is, for example, traffic tiles. So they're cached for a little while, but when the user pans somewhere else, eventually we evict them from the cache, and if the user comes back, we'll re-download them. That basically covers the scenario of the traffic tiles.
And like before, it's a WinINet cache, so the same caching rules on the response you send back will be respected.
Is it possible to do some app, as Gmaps, for example, which does show you some map from some other source, and to cache that data? Is there ways to do that?
You can do that. We can follow up on afterwards with you, but essentially with the tile source we're exposing, this controls a little bit heavier weight, and so if you want to completely replace the entire map and not use any of the features of it, we probably wouldn't recommend doing that with this control. Use the Bing control because that's a lighter weight, and you can essentially tell it not to load the maps. we'll always be loading the maps behind you and potentially having a data cost for that. So it's more of an overlay. We actually situate our tiles so there's some of the map layers show on top of the tiles now as well.
For the routing data, when you're using the maps, do you focus mostly on street data, or do you have bike paths, walking paths, public transportation?
For routing, we have two modes. We have both drive and walking.
Drive and walking.
Okay, I think this is it.
And what about
Last question.
mass transit mode?
Mass transit, we don't have anything. Our routing API doesn't expose a mass transit mode. You can, of course, hook one up and then draw your polylines to do it, but nothing built in.
Okay,
Great.
thank you very much. And please do not forget to fill in your evaluations. Thank you.